In this video, we're going to look at the relationship between indices and logarithm. That actually means how does logarithm relate to indices, or how does indices relate to logarithm. So basically what we're going to do is how you can convert from indices to logarithm, or how you can convert from logarithm to indices, the relationship. So let's take examples. If log 1 to base n is equal to x, what's the value of x? First thing first, let me start by saying that remember that indices, if we're given a function such as x raised to the power n equals to a. Now this is indices, that means x raised to the power n is equal to a, and x raised to the power n is a shortened form of say x times x raised to and that x times x continuously until it gets a number n, so which means that x multiplies itself repeatedly according to the number we have here. So if x is 2 raised to the power 3, it means x multiplies itself 3 times. So when x multiplies itself 3 times, the result will give us a. So let's use this is a number typically. Let's say 2 raised to the power 3. When 2 raised to the power 3 implies that 2 should multiply itself repeatedly 3 times. 2 times 2 times 2. And that's, what is that? 2 times 2 is 4, 4 times 2 is 8. So that is 8. So this is what it means in index form or index notation. But in logarithm form, this index notation, we can get the logarithm. So this will give us the logarithm of 8. The logarithm log 8. So log 8 base 2. Log 8 to the base 2 is equal to 3. That's what it implies. So from index, we can get the logarithm of it, and from the logarithm we can get the index. So from index, just this base becomes our base in the log, and then this 8 becomes the log value, which is log 8, and then 3, which is the power, becomes our result in log form. Then from the log form, we get the index. In the index notation, just bring 2 to this side, that means 2. Then this 3 will become the power 2, which is the base here, and 2 raised to the power 3 will be left with 8, equal to 8. So this that implies that we can, from index notation, get the same function in logarithm form, and from logarithm form we can still get from logarithm form we can get back to the index notation. So that's exactly what we want to look at in this video or this lesson. So our says if log 1 to the base n is equal to x, what is the value of x? Log 1 to base n is equal to x. So in that case, this is the base, and this is the value or the result in this log function. Now, converting to index form, let's converting to index function or notation. So this base n is to the power x is equal to 1. N is to the power x is equal to 1. So now if it's equal to 1, it means that n was equal to 0. So that means but I'm going to say but 1 is equal to n raised to the power 0. For indices, any base raised to the power 0 is equal to 1. So we put this in place of this. So n raised to the power x is equal to n raised to the power 0. And so since the base is the same on both sides, since the base is the same on both sides, we equate powers. So we equate powers. That implies that x is equal to 0. So that's your answer for number 1. Number 2, if log x to the base a is equal to p, express x in terms of a and p. So to express x, this letter in terms of a and p means x should be the subject of the formula. So first thing we need to convert this to index notation. Changing to index notation, changing to index function or notation, index function or notation. So log s to the base a equal to p will give us x e raised to power p is equal to x. So since x is already the subject of the formula here, there's nothing that needs to be done anymore because x is already the subject of the formula. So therefore x is equal to e raised to p. That's your answer. Number 3. If log 16 to the base 2 is equal to 4x minus 1, so this will give us converting to index function. This will give us 2 raised to 4x minus 1 is equal to 16. And 16 can be written in index notation as well as both 16 is equal to 2 raised to power 4. 2 raised to power 4, so we say 2 raised to 4x minus 1 is equal to 2 raised to power 4. 2 raised to power 4. So equating powers. So anytime the base is the same, we equate powers. Anytime the powers are the same, we equate bases. Equating powers, since the bases are the same, equating powers, and then have 4x minus 1 is equal to 2. Collect like 10. 4x is equal to 2 plus 1. 4x is equal to 3. And x is equal to 3 over 4. That's the answer. Number 4. If log x to the base 9 is equal to 1.5, log x to the base 9 equal to 1.5. So writing the expression in index form or notation, we're going to have 9 raised to 1.5 is equal to x. So we will say but 1.5 is equal to 1.5 is a decimal expression, a decimal number, but the equivalent of it is equal to 15 over 10. And here 5 into 15 is 3, 5 over 2, that's 3 over 2. So let me say 9 raised to 3 over 2 is equal to x. 9 raised to 3 over 2 is equal to x. And 9 is 3 raised to the power 2 raised to 3 over 2 equal to x. So these two we divide 2 here, 1, 2 here, 1. That will give us 3 raised to the power 3 is equal to x. So x what? X is 3 raised to the power 3. That is equal to 27. 3 raised to the power 3 is equal to 27. So 27 is equal to x, and therefore x is equal to 27. That's for number 4. Number 5. Solve for x in equation log 32 to the base 8 plus x plus 2. So converting the index function. The index function is e raised to x plus 2 is equal to 32. This can be written as 2 raised to the power 3, 2 raised to the power 3, x plus 2. And this is 2 raised to the power 5. So since the base is the same, we equate powers. This will give us 3x plus 2 equal to 5. 3x is 3 times x, 3x equals 2 plus 6 equal to 5. So this will give us 3x equal to 5 minus 6. 3x equal to minus 1. And so 3x equal to minus 1. X equal to minus 1 over 3. Final answer. Number 1. Solve the equation log x raised to the power 2 to the base 2 equal to minus 6. So changing to index function, x raised to the power 2 is equal to 2 raised to minus 6. And okay, so x raised to the power 2 minus 6. This will give us x raised to the power 2 is equal to 1 over 2 raised to the power 6, and that will give us 2 raised to the power 3. So x raised to the power 2 is equal to 1 over 2 raised to the power 3 or raised to the power 2. So now since the powers are the same, we equate bases. So x is equal to 1 over 2 raised to the power 3, and that is equal to x is equal to 1, 2 raised to the power 3 is equal to 8. Either you use this formulation or you say x equals to 8 raised to minus 1. Number 2. Given that 10 raised to x is equal to 3, 10 is equal to 3, express log 300 in terms of x. So 10 raised to x equal to 3, so I'm going to say writing the index function in logarithmic form. We're going to have 10 raised to x equal to 3 will give us log x to the base 10 will be equal to log 10 to the base 2 equal to x. Next we seek to express log 300 to the base 10 in terms of x. So now log 300 to the base 10 is equal to log 100 times, okay, let's select 2 times 100, and that is log 3 to the base 10 plus log 100 to the base 10, log 3 to the base 10 plus log 10 raised to the power 2 to the base 10, and to go on, we're going to have log 3 to the base 10 plus 2 log 10 to the base 10. Now we're told that from the question it says, given that 10 raised to the power x is equal to 3, express log 300 to the base 10 in terms of x. Now in terms of x means that x should be a solid formula, and what is x here? X is equal to log 3 to the base 10. So log 3 to the base 10, we'll put x in place of it. This will be equal to, okay, let's say but log 3 to the base log 3 to the base 10 is equal to x. So where we have log 3 to the base 10, we'll put x here, and that will be equal to x plus 2 log 10 to the base 10 is 1 and that's equal to x plus 2, the final answer. So this is log 200 to the base 10 in terms of x, where x is equal to or stands for log 2 to the base 10, which is this equation, log 2 to the base 10. Okay, x plus 2. Number 3, if log p to the base 2 is equal to 3, then p is equal to 2 raised to the power 3. So p is equal to 2 raised to the power 3 is 8. So that's the answer. Number 4, given that log x is 64, log 64 to the base x is equal to 3. Okay, evaluate x log 8 to the base 2. So because we are going to essentially evaluate log 8 to the base 2, that implies that our working here would somehow look like what we have here. So our base here would be 2, and eventually 8, we're going to have 8 here as the logarithm of 8. So okay, let's work. So log x 64, I'm going to write this in writing the expression above, index notation. Writing the expression above in index notation, we're going to have log x raised to the power 3, x raised to the power 3 is equal to 64. Okay, now 64, this will give us x raised to the power 3 is equal to 4 raised to the power 3, and that will give us, since the powers are the same, we equate base. So therefore x is equal to 4. So x is equal to 4. Now evaluate x log 8. Therefore, now that we've gotten the value of x will be 4. So next evaluate x log 8 to the base 2. So this will give us where x is equal to 4. So we're going to say x log 8 to the base 2 is equal to, what is it? That's 4 log 8 to the base 2, and this will give us 4 log 2 to the power 3 to the base 2. And this will give us 3 times 4 log 2 to the base 2. We're going to say but log 2 to the base 2 is equal to 1. Therefore 4 log 2 raised to the power 3 to the base 2 is equal to 3 times 4. 3 times 4 times 1. And 3 times 4 is what? 12. That's the answer. The final answer is 12. So initially I said, when I started, I was trying to say that for you to get this part that you need to evaluate, you need to make this part look like this. But exactly what you needed to do was to get the value of x, which when converted to index notation, x was the base. So once you get the value of x, which is the base, then you know what x here means, and then evaluate accordingly. You get to this form, and then you go to 12.